Hello everyone. We are going to learn 12.2 today. So let's take a look. It's all about vectors. So firstly, let's take a look at force, velocity, and displacement. Actually, they are all quantities have magnitude and direction, right? When we talk about force and velocity, they have direction. So we call those quantity vector. So let's see. That's the first definition. Vector definition. Vector is used to indicate a quantity that both have both magnitude and direction. So magnitude of velocity actually is speed. Speed has no direction, but velocity has direction. So actually velocity is a vector. So magnitude and the direction. And we use a directed line segment to represent a vector. It is represented by directed line segment. Okay, so now let's see how we draw the vector. If it's in 2D plane, so it's like xy coordinate, right? And we say here we use a directed line segment. And its line segment, we know this has initial point, and we call B is terminal point. And A is called the initial point. Okay, so that's the definition of vector. And let's see, we take a look at the magnitude of vector is called the length. Length of vector is the magnitude. And it's represented by, so like this way, A, B is kind of like F's value, and this means the length of the vector. And the two vectors are equal if they have the same length and the same direction. Two vectors are equal if they have same length and direction. We can take a look. For example, here we have vector like u. Okay, let's say vector AB. And then we have another vector. They have the same direction, same length, CD. Then we say they're the same thing. And for the vector, how do we express them? So we do like A, B, right arrow on top. So that means A is initial point, B is terminal point, and equals vector CD. Okay. That means if they have same direction and same length. Right now, let's take a look. We are going to move the vector AB here. So we can see those two vectors have the same length and the same direction, right? And in this case, we call the second, this new vector is same as AB. This is called the standard position. Position of the vector, okay, of vector AB. Standard position means initial point at origin. Now let's take a look at the notation. How do we write down the vectors? If the vector V is a two-dimensional. We also have three-dimensional. In the future, we will have an n-dimensional, two-dimensional space, a plane. In the plane. With initial point at origin. That means at the standard position. And terminal point is given by a coordinate. And terminal point, we say V1, V2. Then the component form of the vector V is given by this way. So let's take a look. We write down the vector just as V1, V2. Okay. So for example, if we have vector look like this, start at origin, and the terminal point here is 2, 3. So this is 2D vector, right? Because it's in 2D. And we express this vector just as 2, 3. Something like that. Okay. Component form. And if V is in 3D, so we write down the vector as V1, V2, V3, 3 components. And V1, V2, V3, they are called components of the vector. So, for example, the vector equals 3, 4, -1. This is a 3D vector, right? And then now let's take a look how to calculate the magnitude or length of a vector. So if our vector looks like this, for example, if it's in 3D, or length, they are the same thing. Okay, magnitude or length of a vector. The vector is given by, if in 3D, V1, V2, V3 is this one. Okay, defined by the length. We write down kind of like X value. So actually, what's the length? If you just look at the point here, so V1, V2, V3, that's the coordinate of this point, right? And what's the length? We know how to calculate the length between 2 points. In 12.1, we know how to find the distance. So here is the distance from origin to V1, V2, V3. So this is also the length of the vector. So actually that is V1 square plus V2 square plus V3 square. So it's kind of like a V1 minus 0 square, V2 minus 0 square plus V3 minus 0 square, right? Something like that. And this is the standard form, okay, standard position. And in general, our vector, so if we have our vector initial point is like x1, x2, x3. Sorry, let's do another way. So for example, if our points are like in 3D, here is our vector PQ. P is initial, Q is terminal, and the Q is given by x2, y2, z2 in 3D, so it should be something like that, for example. And the P is x1, y1, z1, 2 points. And the length of this vector is actually just a distance. So same as before, x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Something like that. Okay, that's the vector. And the zero vector, we define zero vector as this. This is zero vector in 2D, and the zero vector in 3D is just origin. Okay, 0, 0, 0. And then now let's take a look at the example 1. Find the component form of the vector. Okay, given initial point and the terminal point. Here is example 1. Find 2 questions. A, component form. 2, B, length, okay, of the vector with initial point P, Q, okay, this is an example. Now let's take a look how to find the component form of this vector. So for the component form, for example, if we have point P, we have point Q, and we say this vector PQ, right? So PQ always equals terminal point minus initial point, always equals to terminal point minus initial point. So in this case, it just equals to negative 5, 2, 2 minus, actually we can write down in a better way. So it's like negative 5 minus negative 3, okay, and 2 minus 4, terminal, which is Q minus P, so 2 minus 1. Let's simplify. So it should be negative 2, negative 2, 1, right? So this is a PQ vector. So why we have PQ, why we do this way, always use terminal point minus initial point. I'm going to show you actually in 2D, if we have 2 points P and Q, and here's the vector we are looking for, right? And actually, if we connect origin and the P, and we can get vector OP and vector OQ. Okay, so if we say this is vector V, this is U V vector, so this vector actually is U plus V. So you can see the PQ vector, which is also the V vector, so we can say U plus V is OQ vector. Okay, OQ vector. So OQ vector is just given by the coordinate of Q, which is terminal point, negative 5, 2, 2, right? Okay. And so actually how to find the V vector? The OQ vector, so PQ vector, which is OQ vector minus OP vector. So which is OQ is the terminal point, terminal minus initial. Okay, that's why we always use terminal point minus initial point. So let's see, if we have vector, for example, if we have vector equals 1, 2, the point is A is 1, 2, and the B is 3, 4. So AB vector equals what? Terminal minus initial. So 3 minus 1, 2, and 4 minus 2, which is 2. And then if we look at BA, terminal point becomes A, so it should be 1 minus 3, 2 minus 4 in this case, negative 2, negative 2. Okay, just opposite to each other. So this is the magnet component form of the vector, right? Next, we are going to find the length. The length of the vector, so here PQ vector, the length, just using the formula. So here is x2 minus x1 squared, y1 squared, z2 minus z1 squared, and now plug in those points. Okay. So x2 minus x1, so it should be -5 minus -3. So it should be -5 plus 3 squared and plus the second point, which is 2 minus 4 squared. 2 minus 1 squared, and after we simplify, so it should be 4 plus 4 plus 1 should be root of 9, which is 3. Right, so this is how we find the length. And also you can do another way. For the length, we already find the PQ vector. Where is our PQ vector? Is here. Okay, and you can do this one. PQ vector is just the root of v1 squared, v2 squared, v3 squared, and which is just root of 4 plus 4 plus 1 equals 9. Actually, the second method is better because we already found the components and this is faster, right? We can just use this way. Now let's try exercise. If we have point P, Q, let's find PQ vector, QP vector, and PQ vector length. Okay. Now I'm going to write down the solution to this one, and it's good for you to do this by yourself. PQ vector, terminal point minus initial point, Q minus P, so -2 minus 3, -5. 5 minus -2, 7. And the QP, if you don't want to do the calculation, just switch the number into negative of the components. Okay, because that is like a opposite way. x2 minus x1 become x1 minus x2, right? And what is the length? PQ vector length, just square root of component square. So it should be root of 25 plus 49, root of 64. Yeah, this is the length. Okay, so this is the definition of the length of vector and example. Now let's take a look at the next definition, the addition and the scalar multiplication of vectors. Definition 5. So here we have two vectors. U equals U1, U2, U3. And the V vector is given by V1, V2, V3. Okay. And the K is a scalar. Scalar, also sometimes we call that constant, right? But in vector, space, we usually call that scalar. The first definition, addition of two vectors. So U plus V, the vector, we just add their components together. So U1 plus V1, U2 plus V2, U3 plus V3. This is called the sum. And the scalar multiplication. We use K, that means if we use scalar times a vector U, so we can just use the scalar times every component of the vector. KU1, KU2, KU3, something like that. And it seems you can see if we want to calculate the difference subtraction of two vectors, so you can treat this as U vector plus 91 times V vector, right? So actually this is U1 minus V1, U2 minus V2, U3 minus V3. Okay, so it's not given by formula. If we know addition and scalar multiplication, we can do a lot of calculations between vectors. Now let's take a look at example 2. So here we have two vectors, -1, 3, and 1, and the V vectors are given is also given, so 470 components form. So we want to find the first one, 2u plus 3v. Okay. Second, u minus v. Third, 2u vector length. Okay, now let's take a look at this one. Firstly, let's take a look at the 2u plus 3v. So 2u plus 3v is kind of like scalar multiplication and then addition, right? So we say 2, so which is -131 plus 3v, 470. Simplify scalar multiplication times every component by scalar, 6, 2 plus 12, 21, 0, and add each component, corresponding component. So 92 plus 12, 10. 6 add that 1, 27, and 27. Okay. Oh, sorry. The last one is 2. 2 add 0, which is 2, not 27. Okay. I saw the bracket is 7, so it should be 2. This one is 2. That's the first one. Next one, u minus v, just equals 9131 minus 470. We just do subtraction of each component. 91 minus 4, 95. 3 minus 7, 94, and 1. Okay, this is subtraction. Now let's take a look at the length of the 2u. So I'm just going to write down this way directly. So we are going to find the 2u vector. So 2u should be -2, 6, and 2. Is that right? 2u, 2 times the u. And now take the length of this one, so root of each square. -2 square, 6 square, 2 square, which is root of 4 plus 36 plus 4. So which is root of 44. If you want to simplify, 2 root of 11. Okay. So that's just a calculation of the vectors. And now let's take a look at properties of vector operation. We can give by theorem. Okay. Properties of vector operation. Oh. Let's see, the first one, u plus v vector, which is v plus u vector. We can switch the order because it's sum. The second one, u plus v at w, we can do the sum of v and w first because it's always the sum, right? This is kind of just a law of the sum. And the third one, u vector plus 0 vector. Be careful, it's not 0, it's 0 vector. It's same as 0 because 0 vector also has components. Number 3, u vector minus u vector, which is 0 vector. Number 4, here a is constant or scalar and b is also scalar, and this one we can write down as ib times the vector u. And here we say a, b are scalars. Number 5, 1 times u vector, which is just a u vector. It's like 1 times every component of u, so same as the vector u. Number 6, 0 times u vector is 0 vector. We can distribute the vector, so it's au plus bu. Number 8, au plus v equals au plus ab. Okay, those are the properties. Now let's take a look at another definition. So in this section, we do have a lot of definitions because this is like introduction section. Unit vector. So What is called a unit vector? So whenever we call unit, that means kind of a length is 1. Okay, so it's a vector of length 1 is called a unit vector. The standard unit vectors, we have some standard unit vector. Okay, so they are 1, 0, 0, and we define, usually we write down them as I. J equals 0, 1, 0, K 0, 0, 1. Okay, they are called standard unit vectors. And if you look at the length of those vectors, they have the length 1. Now let's take a look at our vector, general vector. So if our general vector has components v1, v2, v3, we can write this as sum of v1 times 1, 0, 0 plus v2 times 0, 1, 0 plus v3 times 0, 0, 1. Because v1, v2, v3, they are scalars. And this is just like a v1i, v2j, v3k. So for general vector, another way to write down the vector is using this way. And the I1 is S component, we call that S component. And this v3 is like a K's component. For example, if we have vector given by 1, 2, 4, okay, we can write down this as another way, which is 1 times I, so just I, 2j plus 4k. They both represent the same vector. You can use either way. Okay. Now let's take a look at the vector. P, we have 2 points, P, x1, y1, z1, and P2, P1, P2, x2, y2, z2. They are the coordinates for the points, right? And if we want to find those 2 vectors, like P1, 2, PQ, P2. Okay. So let's see how to write down the vector. P1, P2 vector. We know we use the initial terminal point minus initial point, so which is x2 minus x1, and y2 minus y1, z2 minus z1, and we can also write down this as x2 minus x1i, y2 minus y1j, z2 minus z1k. Okay. So for example, we can find if we have a point P, 5, 7, negative 1, and we have P2, 2, 9, negative 3. Let's see. Let's find the P1, PQ, P2. So here's kind of same thing review, right? But we just write down the other method the other way. So P2 is terminal point 2 minus 5, negative 3i. Okay, and 9 minus 7, 2j. Negative 3 minus negative 1, so negative 2, negative 2k. So P1, P2. The vector is given by this way. Now let's see, for a general vector, this one, how to find the unit vector. So we know the vector, for example, for the vector v, how to find the unit vector? Just divide by the length. Okay, because the vector has a length, for example, if the vector, here, the v vector has the length 5. It's like 1, 2, 3, 4, 5. Length is 5, right? How to find the unit vector? Still in the same direction, right? So how to find that? just use the vector here, the v vector, divide by 5, and then become the unit length 1 vector. So that's the unit vector. This is how we find the unit vector. And if you want the proof, the length of that one is just 1. So definition 7, how to find the unit vector? This divide by that is unit vector, right? Is a unit vector, and we call that, there's a name for this vector, is a unit vector in the same direction. If you look at my graph here, same direction as the v vector is called the direction of vector, is unit vector, and is called the direction of. Also, it has to be non-zero vector, otherwise denominator will be 0.